All right, so this is take 2 in my conversation about triangular prisms. First take, my dog started barking, so we'll see if we can get through this one without that kind of interruption. I've got a triangular prism here, and the first thing we need to ask ourselves sometimes when we look at these three-dimensional shapes is, where are the bases? And you got to remember, for a prism, there are two bases, and they have to be both parallel, and they have to be congruent. So the only faces on this shape that are both parallel and congruent are these triangular faces. And here in the orientation shown, that's actually the front and the back, not the top and the bottom. So if it's easier for you to redraw the shape so that the base is actually the face that the shape is sitting on, think about tipping this up on end, and you can redraw it and it'll look something like this. And I find this can be a little bit helpful because I do like to think about the base as being the top and the bottom. So I've got the same dimensions here, but I've got these triangular faces on both the top and the bottom. So let's take a look at the area of those faces. So we've got a triangle. When I calculate the area of a triangle, it's 1/2 base times the height, but we need to remember that the base and the height have to be perpendicular to each other. So we need to ask ourselves, do we have a right triangle here? And ding, 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 the way we would figure that out is Pythagorean theorem. So let's take a look. If it's a right triangle, the legs would be the shorter of the two. So 9 squared plus 12 squared. Does that equal 15 squared? And in this case, conveniently, yes, it does. So we have a right triangle. So we know this is a right angle here. And again, it might help you to just redraw the triangle so that my base and my height actually look like the base and the height. And let's go on and figure out that area. So I've got an area of 1/2 times the base of 12 and the height of 9. That gives me 54. And remember, there's a top and a bottom. So let's multiply that by 2. And so we get an area of 108. And I guess I didn't put units here. They would be square units. 108 for both of those bases. So now let's take a look at the lateral surface area. And remember, the lateral area are the sides. And here, I think it's going to be helpful if we think about drawing a net of this shape. We talked about nets in our last lesson. And let's think about just kind of cutting this shape on its edges and unfolding it so that we end up with a rectangle this direction. We end up with another rectangle this direction. And I'm realizing I never put a dimension here. This is 10. So we've got 10 here for the height, and we've got just now a long rectangle. If we unfold this face, we get a dimension of 12 from here to here. So likewise, here to here would be 12. If we unfold along this edge, we'd have a dimension of 9 here. So again, 9 would be down here. So now we've got a large rectangle that represents that lateral surface area, and we've got 9 plus 15 plus 12, that would be 36. So the area of that rectangle is the base times the height, so that'd be 36 times 10, so 360. So we've got a lateral area of 360 square units, whatever that might be. And then if we want to think about the surface area, remember, surface area is our total. So we're going to look at the bases, 108, and then the lateral area, 360, and we're going to end up with a total surface area of 468 units squared.